The Fermi Paradox is the most disturbing question in science. There are 2 trillion galaxies in the observable universe. Each galaxy contains hundreds of billions of stars. Almost every star has planets. The universe is 13.8 billion years old. The math says alien civilizations should be everywhere. The silence says they are nowhere. 0 signals, 0 evidence. The universe is completely terrifyingly silent. Where is everyone? In the summer of 1950, 4 physicists walked to lunch at the Fuller Lodge dining hall in Los Alamos, New Mexico. The men were Enrico Fermi, Edward Teller, Herbert York, and Emil Konopinski. They were nuclear physicists. They built bombs. They understood numbers better than almost anyone alive. They spent their days calculating the behavior of the most powerful forces in the universe: nuclear fission, nuclear fusion, the energies that power stars and destroy cities. These were not dreamers. These were not science fiction enthusiasts. These were the hardest-headed, most rigorous, most mathematically precise scientists on the planet. On the walk to lunch, the conversation turned to flying saucers. A recent New Yorker cartoon by Alan Dunn had shown aliens stealing trash cans from New York City, and the physicists were laughing about it. There had also been a rash of UFO sightings in the news. This was 1950, the dawn of the flying saucer era. The conversation was light-hearted, jokes about interstellar travel, about faster-than-light propulsion, about little green men. Teller, characteristically, started calculating the probability of faster-than-light travel. Fermi, characteristically, started calculating the probability of anything at all. They sat down to eat. The conversation moved on to other topics. And then, in the middle of lunch, with no preamble, with no connection to the current discussion, Enrico Fermi suddenly said, "Where is everybody?" The table went quiet. Everyone immediately understood what he meant. Not where is everybody in the dining hall. Where is everybody in the universe? If the universe is as old as we think it is billions of years, if there are as many stars as we think there are hundreds of billions in our galaxy alone, if the conditions for life are not impossibly rare, if intelligence is not a one-time miracle, then the universe should be teeming with civilizations, advanced civilizations, civilizations millions of years older than ours, civilizations that have had time to colonize entire galaxies, civilizations whose signatures should be visible across interstellar distances. Where are they? Fermi did a quick calculation at the table. He estimated the number of stars, the probability of planets, the probability of life, the probability of intelligence, the time it would take a civilization to spread across the galaxy. His conclusion: they should be here. They should have arrived long ago. The galaxy should be colonized. The evidence should be overwhelming, but the evidence is zero. No signals, no probes, no artifacts, no megastructures, no evidence of engineering on cosmic scales, no messages, no visits, nothing. The universe is silent. The galaxy is empty. As far as we can tell, we are alone. This is the Fermi Paradox, and it is, in my opinion, the most disturbing question in all of science. More disturbing than dark energy, more disturbing than quantum mechanics, more disturbing than the nature of consciousness. Because the Fermi Paradox is not about physics or mathematics or abstract theory. It is about us, about whether we are alone, about whether anyone else has ever looked up at the stars and wondered what they are, about whether the universe has produced consciousness once or a billion times or everywhere, or only here, on this one pale blue dot, in this one spiral arm of this one ordinary galaxy. Every other question in science, what is dark matter? How does consciousness arise? What happened before the Big Bang is a question about the universe. The Fermi Paradox is a question about whether the universe cares, whether it produces minds as a matter of routine or as a once-in-an-eternity miracle, whether intelligence is a cosmic commonplace or a cosmic aberration, whether the story of consciousness is a universal story told across trillions of worlds or a local story told once, here, and nowhere else. Let me give you the numbers, because the numbers are what make this a paradox and not just a question. The observable universe contains approximately 2 trillion galaxies, 2,000 billion galaxies. Each galaxy contains, on average, 100 billion to 400 billion stars. The total number of stars in the observable universe is approximately 1024, a 1 followed by 24 zeros. A trillion stars. You cannot comprehend this number. No one can. If you counted 1 star per second, it would take you 30 trillion years to count them all. The universe is only 13.8 billion years old. You would need 2,000 universe lifetimes to finish counting. Now narrow the focus. Just our galaxy, the Milky Way, one ordinary spiral galaxy among 2 trillion. The Milky Way contains between 100 billion and 400 billion stars. Current estimates center around 200 billion. 200 billion stars in our galaxy alone. How many of those stars have planets? We did not know the answer to this until recently. The Kepler Space Telescope, launched in 2009, changed everything. Kepler stared at a single patch of sky for 4 years, monitoring 150,000 stars for the telltale dimming that indicates a planet crossing in front of its star. The results were revolutionary. Almost every star has planets. The fraction of stars with at least one planet is close to 100%. Some estimates put it above 100%, meaning the average star has more than one planet. The Milky Way contains more planets than stars. Current estimates suggest at least 100 billion planets in our galaxy, probably several hundred billion. Think about this. Every star you see in the night sky, every single one, almost certainly has planets orbiting it. When you look up on a clear night and see a few thousand stars with your naked eye, you are looking at a few thousand planetary systems. When the Hubble Space Telescope photographs a deep field image containing 10,000 galaxies, it is photographing trillions upon trillions of planetary systems. Planets are not rare. Planets are everywhere. The universe is drowning in worlds. How many of those planets could support life? This depends on the habitable zone, the range of distances from a star where liquid water can exist on a planet's surface. Not too hot, not too cold. The Goldilocks zone. Kepler found that approximately 20% of Sun-like stars have an Earth-sized planet in the habitable zone. In the Milky Way, that translates to roughly 8 to 20 billion potentially habitable Earth-like planets orbiting Sun-like stars alone. Include red dwarf stars, which are far more numerous, and the number rises to perhaps 40 billion potentially habitable worlds in our galaxy alone. 40 billion chances for life in one galaxy among 2 trillion galaxies. The total number of potentially habitable planets in the observable universe is roughly 10 billion trillion. That is more habitable worlds than there are grains of sand on every beach on Earth. Every grain of sand you have ever walked on, every grain on every beach you have never visited, every grain in every desert and every riverbed. And there are still more potentially habitable worlds than all of those grains combined. These are the numbers. These are not speculations. These are not optimistic estimates from science fiction enthusiasts. These are conservative calculations based on the best observational data from Kepler, TESS, and ground-based surveys. The universe is unimaginably vast. It is unimaginably old, and it is unimaginably full of places where life could potentially exist. In 1961, 11 years after Fermi's lunchtime question, astronomer Frank Drake formalized the problem. He wrote an equation, the Drake equation, that breaks the question into a series of factors, each representing a step on the road from stars to civilizations. The equation is n equals r times fp times ne times fl times fi times fc times l. N is the number of detectable civilizations in the galaxy right now. R times is the rate of star formation in the galaxy. We know this. About 1 to 3 new stars per year. Fp is the fraction of stars with planets. We know this now thanks to Kepler. Close to 1. Ne is the number of habitable planets per star with planets. We have good estimates, roughly 0.2 to 0.5 for Sun-like stars. Fl is the fraction of habitable planets where life actually develops. We do not know this. This is the first great unknown. Fi is the fraction of life-bearing planets where intelligence evolves. We do not know this either. Fc is the fraction of intelligent civilizations that develop detectable technology. Unknown. L is the length of time such civilizations produce detectable signals. Completely unknown. This is perhaps the most important factor and the most terrifying, because L determines everything. If civilizations last 1 million years, the galaxy could be full of them. If civilizations last 100 years, if they destroy themselves within a century of developing radio technology, then the galaxy could be a graveyard of civilizations that flickered into existence and snuffed themselves out before anyone could notice. We have been transmitting radio signals for about a century, 100 years out of 13.6 billion years of galactic history. If L is short, if civilizations routinely destroy themselves, then our century of radio transmission is a candle lit in a hurricane, briefly visible, then gone. Drake's original estimate, made with a small group of scientists, including a young Carl Sagan, produced a number between 1,000 and 100 million civilizations in our galaxy. Even the conservative end 1,000 civilizations means we are not alone. Even 1,000 means the galaxy is populated. Even 1,000 means someone should have noticed us by now, or we should have noticed them. The optimistic estimates millions of civilizations imply a galaxy teeming with intelligence. A galaxy where civilizations are the norm, not the exception. A galaxy where someone, somewhere, should be shouting into the void at a volume we can hear, but the void is quiet. The silence becomes even more paradoxical when you consider the timescales. The Milky Way is 13.6 billion years old. The first generation of stars formed within 1 billion years of the galaxy's birth. The heavy elements necessary for rocky planets, carbon, oxygen, silicon, iron, were synthesized in those early stars and distributed through supernova explosions. By 4 billion years after the galaxy's formation, there were plenty of heavy elements for planet formation, plenty of rocky worlds in habitable zones, plenty of opportunities for life. Earth is 4.5 billion years old. Life appeared on Earth almost immediately within the first few 100 million years, possibly within the first 100 million years. If the emergence of life is a rapid process, if it happens quickly whenever conditions are right, then life could have appeared on other planets billions of years before it appeared on Earth. Billions of years. Think about what that means. Human civilization is roughly 10,000 years old. Modern technology is roughly 200 years old. We have gone from horse-drawn carriages to spacecraft in 200 years. From sending the first radio signal to landing on the moon in 70 years. From the first computer to artificial intelligence in 80 years. Now imagine a civilization with a billion-year head start. A civilization that started its technological development when our solar system was still a cloud of gas and dust. A civilization that has had 1 billion years to develop technologies we cannot imagine. To put this in perspective, 1 billion years ago, the most complex life on Earth was single-celled organisms and simple multicellular colonies. No animals, no plants, no brains, no eyes. Nothing that would recognize itself as alive in any meaningful sense. The distance between single-celled life and human technology, the entire journey from microbe to moon landing, fits into 1 billion years. What lies on the other side of that same distance? What technologies exist 1 billion years beyond where we are now? We cannot imagine it, any more than a bacterium can imagine a smartphone. The gap is not just quantitative, not just better technology. The gap is qualitative, conceptual. 1 billion years of technological development might produce capabilities that are to us what our technology is to a bacterium, not just more advanced, but incomprehensible, operating on principles we cannot even formulate. What would such a civilization look like? In 1964, Soviet astronomer Nikolai Kardashev proposed a classification system for civilizations based on their energy consumption. A Type 1 civilization harnesses all the energy available on its planet, the total energy output falling on its world from its star. Earth is not yet Type 1. We use roughly 0.73 of what would qualify. We are a Type 0.73 civilization. A Type 2 civilization harnesses the total energy output of its star, not just the fraction that falls on one planet, the entire output, all of it. Freeman Dyson proposed that such a civilization might build a megastructure around its star, a Dyson sphere, to capture all the stellar energy. This would be an engineering project of extraordinary scale, but given enough time, centuries, millennia, it is physically possible. There is no law of physics that prevents it. A Type 3 civilization harnesses the total energy output of its entire galaxy, all the stars, all the energy. This is the level of a civilization that has colonized every star system in a galaxy containing hundreds of billions of stars. This sounds like science fiction, but remember the timescales. 1 billion years. A civilization with 1 billion years of technological development. The things that seem impossible to us, that seem like fantasy, might be trivial to them. Routine, ordinary, the way building a bridge seems to us. Consider, 200 years ago, the idea of talking to someone on the other side of the planet instantaneously was fantasy. 100 years ago, the idea of walking on the moon was science fiction. 50 years ago, the idea of carrying the entirety of human knowledge in your pocket was absurd. Every generation considers the previous generation's impossibilities to be its routine capabilities. Extrapolate this for 1 million generations. For 1 billion years, the word impossible loses all meaning. Arthur C. Clarke put it best: any sufficiently advanced technology is indistinguishable from magic. A Type 3 civilization would not just be advanced, it would be, from our perspective, indistinguishable from God's. Its technology would be indistinguishable from the laws of physics themselves. We might not recognize their engineering because we might not be able to distinguish it from nature. Here is the calculation that makes the paradox so sharp. The Milky Way is about 100,000 light-years across. If a civilization sent out colony ships traveling at just 1% of the speed of light, far below what our own technology could theoretically achieve with nuclear pulse propulsion or light sails, those ships would cross the galaxy in 10 million years. 10 million years. That sounds like a long time. It is not. Not compared to the age of the galaxy. 10 million years is less than 1/10 of 1% of the galaxy's age. The galaxy has been around for 13.6 billion years. A colonization wave traveling at 1% of light speed would have crossed the entire galaxy 1,360 times over. Even if colonization is slow, even if civilizations expand at a leisurely pace, settling one new star system every 1,000 years, the entire galaxy could be colonized in a few 100 million years. A blink of an eye in cosmic terms, and it only takes one civilization, anywhere in the galaxy, at any point in the last few billion years, deciding to expand. One civilization building self-replicating probes. One civilization sending colony ships. One civilization doing what life has always done, spreading, expanding, filling every available niche. This is the key insight. You do not need most civilizations to be expansionist. You do not need half. You do not need 10%. You need one out of potentially millions. One out of potentially billions. In billions of years of galactic history, across billions of potentially habitable worlds, you need exactly one civilization, one time, to decide to expand beyond its home system. Life on Earth has demonstrated this tendency for 4 billion years. Every time life finds a new niche, it fills it. Every time a new continent emerges, life colonizes it. Every time a new environment becomes accessible, deep sea vents, high atmosphere, underground caves, radioactive waste pools, life finds a way in. Expansion is not a peculiar human trait. Expansion is what life does. It is the deepest tendency of biology, of evolution, of self-replicating systems. It only takes one. And given billions of years and billions of potentially habitable planets, the probability that no civilization has ever expanded seems vanishingly small. The mathematician John von Neumann showed that self-replicating machines are theoretically possible. A probe that arrives at a star system, mines the local asteroids for raw materials, builds copies of itself, and sends those copies to the next star systems. Each copy does the same thing: exponential expansion. Even at slow speeds, von Neumann probes could explore and catalogue every star system in the galaxy within a few million years. We could build von Neumann probes with near-current technology. We do not because we lack the will and the funding, not because we lack the ability. If we could almost do it now, at the age of 200 years of technology, what could a civilization do with 1 million years of technology? With 1 billion years? They should have built them, they should have sent them, the probes should be here, in our solar system, around our star, watching us, or at least having passed through, having catalogued this system, having left some trace. Nothing. No probes, no traces, no artifacts, nothing. It gets worse. Even without physical expansion, even without colony ships and von Neumann probes, an advanced civilization should be detectable. Energy use on the scale of a Type 2 or Type 3 civilization would produce waste heat. Infrared radiation, detectable from across the galaxy, from across the universe potentially. In 2015, astronomers Jason Wright and colleagues at Penn State conducted a survey called Glimpsing Heat from Alien Technologies (GHAT). They examined 100,000 galaxies using data from NASA's WISE infrared space telescope, looking for excess infrared radiation that might indicate galaxy-spanning civilizations, Kardashev Type 3 civilizations, harnessing the energy of entire galaxies. The physics is straightforward. Any civilization that captures and uses energy must produce waste heat. This is the second law of thermodynamics. No energy conversion is perfectly efficient. The waste heat must be radiated away, and it radiates in the infrared spectrum. A Type 3 civilization, harnessing the energy of an entire galaxy, would convert that galaxy's starlight into a distinctive infrared glow, different from the natural infrared emission of stars and dust, detectable from millions of light-years away. The result? None. Not one galaxy out of 100,000 showed the signature of a Type 3 civilization. Not one galaxy in the survey showed evidence of a civilization harnessing more than 85% of its total energy output. The universe, as far as infrared astronomy can tell, contains no galaxy-spanning civilizations. None. In 100,000 galaxies surveyed. In 2020, a more refined search looked for partial Dyson spheres, not complete enclosures, but partial structures around individual stars. Structures that would absorb some fraction of a star's light and re-emit it as infrared radiation. 7 candidates were identified. All were later explained by natural phenomena: dusty stars, unusual stellar types, measurement errors. The SETI project, the search for extraterrestrial intelligence, has been listening for radio signals since 1960. Frank Drake himself conducted the first search, Project Ozma, pointing a radio telescope at 2 nearby sun-like stars and listening for artificial signals. Since then, SETI has surveyed thousands of stars across a wide range of frequencies. The result? Silence. 65 years of listening, thousands of stars surveyed, multiple frequencies, multiple detection methods. Not a single confirmed artificial signal. Not one. The WOW! Signal detected on the 15th of August, 1977, by the Big Ear radio telescope at Ohio State remains the closest thing to a detection. A strong, narrow-band signal lasting 72 seconds, matching the profile of an artificial transmission. Astronomer Jerry Amon circled the signal on the printout and wrote, "Wow," in the margin, giving the signal its name. The signal came from the direction of the constellation Sagittarius. Its frequency was 1,420 MHz, the hydrogen line, the frequency emitted by neutral hydrogen atoms, considered by many SETI researchers to be the natural calling frequency for interstellar communication, because hydrogen is the most abundant element in the universe. Any civilization studying the cosmos would know the hydrogen line. Any civilization trying to attract attention would transmit on it. The signal was strong, 30 times louder than the background noise. It rose and fell in exactly the pattern expected for a signal coming from a fixed point in the sky. As the Earth rotated, the telescope's beam swept across the source during those 72 seconds. Everything about the signal was consistent with an artificial extraterrestrial transmission. It was never detected again. Despite repeated observations of the same region of sky, dozens of attempts over the following decades, the signal never repeated. It remains unexplained. But one unrepeated signal in 65 years of searching is not evidence of extraterrestrial intelligence. It is evidence of how quiet the universe is. The Breakthrough Listen project, funded by Yuri Milner with $100 million, began in 2015 and represents the most comprehensive SETI survey ever conducted. It surveys the 1 million nearest stars, the nearest 100 galaxies, and the entire galactic plane across a wide range of radio and optical frequencies. The project uses the Green Bank Telescope, the Parkes Telescope, and the Meerkat Array, some of the most powerful radio telescopes on Earth. As of the mid-2020s, Breakthrough Listen has completed surveys of hundreds of thousands of stars. The results are consistent with all previous SETI efforts. Silence, no signals, no beacons, no leakage radiation from alien technology, no narrowband transmissions, nothing that cannot be explained by natural phenomena or terrestrial interference. The universe is quiet, extraordinarily, disturbingly, paradoxically quiet. Given the numbers 200 billion stars in our galaxy, 40 billion potentially habitable planets, 13.6 billion years of cosmic history. The silence is not just surprising, it is screaming. The absence of evidence is not evidence of absence, as the saying goes. But at some point, after 65 years of searching, after surveying thousands of stars, after scanning entire galaxies in infrared, the absence of evidence starts to become evidence of absence, or at least evidence that something is very, very wrong with our assumptions. Let me put this in perspective. Let me make the paradox personal. You are alive right now, on Earth. In the year 2026, you exist in a galaxy containing 200 billion stars and potentially 40 billion habitable planets. Your galaxy is 13.6 billion years old. Life on your planet appeared almost immediately once conditions were right. Your species went from stone tools to spacecraft in a few million years, a blink of cosmic time. And yet, in all the time this galaxy has existed, through all the billions of years, among all the billions of potentially habitable worlds, in all the vastness of this one galaxy among 2 trillion galaxies, you have heard nothing, seen nothing, found nothing, no signal, no probe, no artifact, no trace of anyone else, ever. Either intelligence is so rare that we are the only example in a galaxy of 400 billion stars which is statistically extraordinary, or intelligence is common but civilizations are silent which demands an explanation, or intelligence is common but civilizations destroy themselves before they can make contact which is terrifying, or they are here and we cannot see them, which is strange, or they exist in forms we cannot recognize, which is humbling, or something else entirely is happening, something we have not imagined, something our current understanding of physics and biology is not equipped to conceive. Each possibility is disturbing in its own way. Each possibility tells you something profound about the nature of reality, the future of consciousness, and the meaning or meaninglessness of intelligent life in the cosmos. If we are alone, truly alone, the only intelligence in a galaxy of hundreds of billions of stars, then we are either the most miraculous accident in cosmic history or the intended product of a universe designed to produce exactly one instance of consciousness in exactly one place. Either way, the implications are staggering. Either randomness produced something so improbable it borders on impossible, or something guided the process. If we are not alone, if civilizations are common, but something stops them from becoming visible, then something is killing them. Something is filtering them out. Something is preventing the galaxy from becoming the crowded, noisy, colonized place that the numbers say it should be. And whatever that something is, whatever kills civilizations or silences them or hides them, it might be waiting for us too. This is why the Fermi Paradox is not just an intellectual curiosity. It is not just a fun question for physicists to debate over lunch. It is an existential question. A question about the future of humanity. A question about whether we have a future at all. Enrico Fermi asked the question over lunch in 1950. 76 years later, we still have no answer. The most brilliant physicists, astronomers, biologists, and philosophers on Earth have grappled with this question for 3/4 of a century. The universe remains silent. And the silence, when you truly listen to it, is the loudest sound in the cosmos. It is a silence that contains within it every possible answer, from the hopeful to the horrifying. A silence that says either we are precious beyond measure or we are doomed beyond rescue. A silence that every generation of astronomers listens to, hoping to hear something, anything, and hearing nothing. In part 2, we explore the most terrifying explanation for the silence. The idea that there is a filter, a barrier, a wall that prevents civilizations from reaching the stars, a great filter that destroys or halts intelligent life somewhere on its journey from single cells to interstellar expansion. The question that keeps cosmologists and existential risk researchers awake at night: is the filter behind us something we have already passed through, something miraculous and unlikely that happened in our past? Or is the filter ahead of us something waiting, something inevitable, something that will destroy us the way it has destroyed every civilization that came before? The answer to that question determines whether the silence of the universe is the best news or the worst news in human history. Something is killing civilizations. Something in the universe prevents intelligent life from reaching the stars. We call it the Great Filter, and it is either the best news or the worst news in human history. If the filter is behind us, we are the luckiest species in the galaxy. If the filter is ahead of us, we are already dead. We just do not know it yet. In 1996, an economist, not a physicist, not an astronomer, not a biologist, but an economist, proposed the most terrifying idea in the history of science. His name was Robin Hanson. He was at George Mason University. He had been thinking about the Fermi Paradox, about the silence, about the emptiness, about the numbers that say the galaxy should be full of civilizations, and the observations that say it is not. And he realized something that the physicists and astronomers had been dancing around for decades without stating it clearly. The logic was brutally simple. Start with two premises. First, the universe is very old and very large, with billions of potentially habitable planets that have existed for billions of years. Second, we see no evidence of advanced civilizations anywhere. Conclusion: something prevents the emergence of visible, galaxy-spanning civilizations. This conclusion is not speculative. It is not a theory. It is a logical deduction from observed facts. The silence is real. The emptiness is measured. Something causes it. If the galaxy should be full of civilizations but is not, then something is stopping civilizations from filling the galaxy. Something is filtering them out. Something is preventing the journey from dead matter to galaxy-spanning intelligence from being completed. Somewhere on that journey, somewhere between the formation of a habitable planet and the colonization of the stars, there is a barrier, a wall, a filter so effective that out of potentially billions of civilizations that should have arisen, none has made it through. None has survived long enough, expanded far enough, or become visible enough for us to detect. Hansen called it the Great Filter. The Great Filter is not a specific event. It is not a single catastrophe or a single failure point. It is whatever combination of factors reduces the probability of the journey from dead chemistry to interstellar civilization to approximately zero. Something makes that journey effectively impossible. And the evidence, the silence, the emptiness, the screaming absence of anyone else proves that the filter exists. The only question is where it is. And the answer to that question is the most consequential piece of information the human species could ever receive, because the filter is either behind us or ahead of us. And the difference between those two possibilities is the difference between being the luckiest species in the galaxy and being the most doomed. Let me walk you through the journey, from dead matter to interstellar civilization, step by step. Each step is a potential location for the Great Filter. Each step is a place where the journey might stop. Step 1. A habitable planet forms. A rocky world in the habitable zone of a stable star, with liquid water, with the right chemistry, with conditions that could support life. We now know this step is easy. Kepler showed us that habitable planets are everywhere, billions in our galaxy alone. This is not the filter. Step 2. Simple life emerges. chemistry becomes biology. Dead molecules become self-replicating molecules. The first cell, the first organism. Abiogenesis, the origin of life from non-life. This might be the filter, because we have no idea how it happened. We know it happened on Earth. We know it happened fast within the first few 100 million years, possibly much faster. But we do not know how. We do not understand the mechanism. We cannot replicate it in a laboratory. Despite 70 years of research since the Miller-Urey experiment in 1953, which showed that amino acids could form from simple chemicals under conditions resembling early Earth, no one has created life from non-life in a test tube. No one has bridged the gap from chemistry to biology. This gap might be enormous. The simplest living cell is extraordinarily complex. A single bacterium, the simplest form of life we know, contains thousands of different proteins, a genome of millions of base pairs, molecular machinery of staggering sophistication. The gap between the most complex chemistry and the simplest biology is vast, and we do not understand how it was crossed. If abiogenesis is fantastically unlikely, if it requires a specific sequence of chemical events so improbable that it happens only once in a trillion planets, then life is almost inconceivably rare. Earth might be the only planet in the galaxy where the chemistry to biology transition occurred, the only planet among 40 billion habitable worlds where molecules learn to copy themselves. The silence of the universe would be explained, not because civilizations destroy themselves, not because intelligence is rare, because life itself is rare, because the very first step, the step from dead matter to living matter, is the filter. The problem is deeper than most people realize. It is not just a matter of making amino acids or nucleotides the building blocks of life. Miller and Urey showed those form easily. The problem is getting those building blocks to self-organize into a self-replicating system, an RNA molecule that can copy itself, or a protocell that can divide, or some primitive system that has the dual capability of carrying information and catalyzing chemical reactions. This is sometimes called the RNA world hypothesis, that life began with RNA molecules that could both store genetic information and catalyze their own replication. But creating self-replicating RNA from scratch has proven extraordinarily difficult. The longest self-replicating RNA produced in a laboratory required careful, intelligent design by biochemists, not the random chemistry of a primordial ocean. The gap between what random chemistry produces and what self-replication requires might be the widest gap in the entire history of life. There is some evidence for this. We have found no life anywhere else. Not on Mars, despite decades of searching. Not in the oceans of Europa or Enceladus, though we have barely looked. Not in the atmosphere of Venus, despite a tantalizing and controversial detection of phosphine in 2020 that was later disputed. Not in the spectra of exoplanet atmospheres, though the James Webb Space Telescope is beginning to search. Everywhere we have looked, we have found only chemistry, only dead matter, only silence. But the evidence is not conclusive. We have barely begun to search, and life appeared on Earth so quickly, so almost immediately, once conditions were right, that it seems like life might be easy. If life were fantastically unlikely, you would expect it to take billions of years to emerge. It took less than a few 100 million. This speed suggests that abiogenesis might not be the filter, that the filter might be elsewhere. Step 3. Complex life evolves. Simple cells become complex cells. Prokaryotes become eukaryotes. This step took 2 billion years on Earth. 2 billion years. Life appeared roughly 3.8 billion years ago. Eukaryotic cells, cells with a nucleus, with internal membranes, with mitochondria, appeared roughly 2 billion years ago. For 2 billion years, life was exclusively single-celled prokaryotes. Bacteria and archaea. Nothing more complex, nothing with a nucleus, nothing with internal structure. 2 billion years is a long time. It is almost half the current age of the Earth. During those 2 billion years, life was stuck, trapped in a simple form, unable to make the leap to complexity. The eukaryotic transition is one of the most mysterious events in the history of life. It appears to have happened exactly once. Every eukaryotic cell on Earth, every cell in every animal, every plant, every fungus, every protist descended from a single ancestral event, a single merger. An archaeon engulfed a bacterium. The bacterium was not digested. Instead, it became the mitochondrion, the powerhouse of the cell. This merger, this endosymbiosis, gave the host cell an enormous energy advantage. Enough energy to support a larger genome, enough energy to build complex internal structures, enough energy to eventually produce multicellular life. But it happened once, in 2 billion years, on a planet teeming with prokaryotic life, trillions of bacteria and archaea, interacting in every conceivable way for 2 billion years. And the eukaryotic merger happened once. Nick Lane, a biochemist at University College London, argues in his book The Vital Question that this single event, the endosymbiotic origin of mitochondria, is the most critical bottleneck in the history of life. Without mitochondria, complex life is energetically impossible. A prokaryotic cell generates energy across its outer membrane. If it gets bigger, its volume increases faster than its surface area. Its energy needs outpace its energy production. It hits a ceiling, a metabolic wall. Eukaryotic cells broke through this wall because mitochondria, thousands of them per cell, provide energy generation across vast internal membrane surfaces. This is what made large genomes possible. Large genomes made complex regulation possible. Complex regulation made multicellular life possible. But the merger that produced mitochondria was not inevitable. It was not a natural progression. It was a freak accident. An archaeon engulfed a bacterium and did not digest it. The bacterium survived inside the host. Over hundreds of millions of years, the two organisms became so interdependent that neither could survive alone. This is not something that happens routinely. This is something that happened once in 2 billion years on a planet saturated with microbial life. Lane argues that the universe might be full of planets covered in bacteria, simple, prokaryotic life, endlessly replicating, never becoming complex. Worlds that have been alive for billions of years and will be alive for billions more, but will never produce anything more sophisticated than a bacterium. If Lane is right, the filter is the eukaryotic transition. The galaxy might be teeming with microbial life and utterly devoid of complex life. Bacteria everywhere, intelligence nowhere. Step 4. Multicellular life develops. This happened on Earth multiple times. Animals, plants, fungi, and several other lineages independently evolved multicellularity. The fact that it happened multiple times suggests it might be relatively easy once you have eukaryotic cells with mitochondria. Step 5. Intelligence evolves. This is where the argument becomes more uncertain. Life has existed on Earth for 3.8 billion years. Intelligence, in the sense of a species capable of technology and abstract thought, has existed for perhaps 300,000 years. Homo sapiens appeared roughly 300,000 years ago. Stone tools appeared roughly 3.3 million years ago, with earlier hominids. But technology capable of producing detectable signals, radio technology, has existed for only about 130 years. Is intelligence inevitable? If you reran the tape of evolution, would intelligence always emerge? Or is intelligence a fluke, a random product of specific evolutionary pressures that happen to produce big brains in one lineage of African apes? Stephen Jay Gould argued that intelligence is a fluke, that if you replayed evolution from the Cambrian explosion, you would get a completely different set of organisms, that there is nothing inevitable about mammals, primates, or intelligence, that the particular evolutionary path that led to human brains was contingent dependent on specific accidents of history, specific environmental pressures, specific genetic mutations that could easily have gone differently. Simon Conway Morris argued the opposite, that evolution converges on certain solutions, that eyes evolve independently dozens of times, that flight evolves independently 4 times, that intelligence is a convergent solution, that evolution will find repeatedly given enough time, that if you reran the tape, you might not get humans, but you would get something intelligent. We do not know who is right. We have exactly one example of technological intelligence. You cannot draw statistical conclusions from a sample of one. But consider this: life has existed on Earth for 3.8 billion years. In all that time, in all the billions of species that have existed, exactly one has developed technology. One. Out of perhaps 50 billion species that have ever lived on Earth. The ratio is 1 in 50 billion. Intelligence, at least on this planet, is extraordinarily rare. Most species are bacteria. Most complex species are insects. Most vertebrates are fish. Intelligence is not the default outcome of evolution. Intelligence is a spectacular anomaly. Dolphins are intelligent. Octopuses are intelligent. Crows are intelligent. Elephants are intelligent. But none of them build radio telescopes. None of them construct civilizations. None of them are detectable from space. There is a vast difference between cognitive sophistication, problem solving, social learning, tool use, and technological civilization. And that gap has been crossed exactly once in 3.8 billion years of evolution on the one planet where we can study it. The evolution of human-level intelligence required a specific and improbable sequence. The extinction of the dinosaurs 66 million years ago, which opened ecological niches for mammals. The evolution of primates in tropical forests. The shift to bipedalism on the African savanna. The development of large brains driven by social complexity. The emergence of language. Each step was contingent. Each could have gone differently. Remove any one of them, and you do not get Homo sapiens. You get a planet full of perfectly successful life forms, none of which wonder about the stars. Step 6. Civilization survives. And this is where the filter might be most terrifying. Because this is the step we are currently on. The step where civilizations either endure or destroy themselves. Consider the timeline. Homo sapiens developed agriculture roughly 10,000 years ago. We developed industrial technology roughly 250 years ago. We developed nuclear weapons 81 years ago. We developed the capability to cause our own extinction through nuclear war, through engineered pandemics, through artificial intelligence gone wrong, through environmental collapse within the last century. In the roughly 250 years since the Industrial Revolution, we have raised the CO2 concentration of the atmosphere by 50%. We have driven a mass extinction event that rivals the 5 great mass extinctions in Earth's history. We have built weapons capable of sterilizing the surface of the planet. We have developed technologies, genetic engineering, artificial intelligence, nanotechnology, whose potential for catastrophic misuse grows every year. We are in the danger zone. Right now, this century, the period between developing technology capable of self-destruction and developing the wisdom to avoid self-destruction. This gap, this window of vulnerability, might be the great filter. Think about the threats. Nuclear weapons we have had the capability to sterilize the planet since the 1960s. During the Cuban Missile Crisis in 1962, the world came within hours of nuclear war. A Soviet submarine commander named Vasily Arkhipov refused to authorize a nuclear torpedo launch against an American destroyer. One man, one decision. The survival of human civilization hung on the judgment of a single submarine officer in a moment of extreme stress. If Arkhipov had said yes, if he had agreed with his fellow officers, the torpedo would have launched. The Americans would have retaliated, the escalation ladder would have climbed, and the world as we know it might have ended. Climate change. We are altering the fundamental chemistry of our atmosphere in ways that could render large portions of the planet uninhabitable. Engineered pandemics, the tools of synthetic biology, are becoming cheaper and more accessible every year. The cost of sequencing a human genome has fallen from $3 billion to a few $100 in 20 years. The capability to engineer pathogens, diseases with higher transmissibility, higher lethality, higher resistance to treatment is no longer confined to state-level bioweapons programs. Artificial intelligence systems that could, if misaligned with human values, pursue goals incompatible with human survival. Each of these risks is relatively new. Each emerged within the last century. Each is growing. And each represents a potential great filter, a mechanism by which a technological civilization could destroy itself before it becomes interstellar. If every civilization that develops technology also develops the capability to destroy itself, and if the probability of self-destruction during the vulnerable period is high, then the galaxy is a graveyard. A galaxy full of planets where intelligent life arose, developed technology, built bombs or engineered pandemics, or created artificial superintelligence, and destroyed itself, over and over, on planet after planet, for billions of years. The astrophysicist Frank Drake, the same Frank Drake who wrote the Drake equation, believed that L, the longevity of technological civilizations, was the critical factor. If L is short a few hundred years, then civilizations flicker in and out of existence too quickly to make contact. They are born, they build, they destroy themselves, and the galaxy moves on as if they never existed. If L is long, millions of years, then civilizations survive, expand, and the galaxy should be full of them. The silence suggests that L is short, or that something else is going on. The philosopher Nick Bostrom made the implications of the great filter viscerally clear in a famous argument about Mars. Imagine, Bostrom said, that we send a mission to Mars, and on Mars we find life, microbial life, simple, single-celled organisms in the Martian soil, prokaryotes, bacteria, the most basic form of life. How would you feel? Excited? Thrilled? The greatest scientific discovery in human history, life beyond Earth? Bostrom says you should feel terrified, because finding life on Mars is bad news, potentially the worst news in human history. Here is why. Think of the journey from dead matter to interstellar civilization as a series of steps. Each step has a probability of being completed. The great filter is somewhere along this journey. It is the step, or combination of steps, with extremely low probability. The filter must exist because the final product, a visible, galaxy-spanning civilization, does not exist. Something prevents it. Now, every time we discover that one of the early steps is easy, that it has high probability, the filter must be located at a later step. It is like a process of elimination. If step 1 is easy, the filter is not at step 1. If step 2 is easy, the filter is not at step 2, and so on. The later the filter, the worse for us. Because the later steps are the ones we have not yet reached. The later steps are our future. If life exists on Mars, if abiogenesis happened independently on two planets in the same solar system, then abiogenesis is easy. Life is not the filter. The filter is not behind us at step 2, which means the filter must be ahead of us. Somewhere between where we are now and where a galaxy-spanning civilization would be, there is a barrier that stops civilizations cold, a barrier that we have not yet reached, a barrier that is waiting for us. The more life we find in the universe, the more common microbial life turns out to be, the worse the news is. Because every step of the journey that turns out to be easy means the filter must be at a later step, and the later steps are our future. If we find complex life on Mars, eukaryotes, multicellular organisms, the news gets even worse. That means the eukaryotic transition and multicellular life are not filters either. The filter must be even further ahead, closer to us, closer to our future. If we find fossils of intelligent life on Mars, evidence that a technological civilization once existed and then vanished, that would be the worst possible discovery. It would mean that the filter is very late, that civilizations routinely reach our level of development and then are destroyed, that whatever killed them is almost certainly going to kill us. Bostrom's argument is counterintuitive. We instinctively feel that finding life elsewhere would be wonderful news, confirmation that we are not alone, confirmation that the universe produces life and intelligence as a matter of course. But the logic of the great filter inverts this intuition. In the context of the Fermi Paradox, finding life elsewhere means the filter is ahead. And if the filter is ahead, our future is short. The most hopeful scenario, the scenario where the great filter is behind us, is the scenario where we are alone, where abiogenesis is almost impossibly rare, or where the eukaryotic transition is a cosmic one-off, or where intelligence is a once-in-a-galaxy fluke. This would mean that the filter is behind us, that we have already passed through the bottleneck, that the journey from here to the stars is, if not easy, at least not blocked by an insurmountable barrier. In this scenario, the silence of the universe is the best possible news. It means we are rare, we are precious, we are the only ones who made it through. The galaxy is empty not because civilizations destroy themselves, but because we are the first civilization in the Milky Way to pass through the great filter, the first to look up and wonder, the first to ask Fermi's question. This is hopeful, but it is also staggering in its implications. If we are the first technological civilization in the Milky Way, the first in 13.6 billion years of galactic history, on a planet that formed 4.5 billion years ago, when the galaxy was already 9 billion years old, then every other planet that had a head start failed. Every world that had billions of additional years of opportunity produced nothing more than bacteria, or nothing at all. We are not just rare, we are the exception that proves the rule of cosmic sterility, and it is lonely, profoundly lonely. It means there is no one to talk to, no one to learn from, no older, wiser civilization to guide us through the dangers ahead. We are on our own, the only intelligence in a galaxy of 400 billion stars, the only consciousness in a cosmos of 2 trillion galaxies, alone in a way that no human being has ever been alone, not alone in a room, not alone in a desert, alone in the universe. Carl Sagan once said that the universe is a pretty big place. If it is just us, seems like an awful waste of space. But what if the waste is the point? What if the emptiness is not a failure of the universe, but a feature? What if the silence is not an absence to be explained, but a fact to be reckoned with, a fact that tells you something about how improbable you are, how precious consciousness is, how extraordinary the chain of events that produced you? But there are other possibilities that do not fit neatly into the great filter framework, possibilities that are stranger, more unsettling, and in some ways more profound. What if civilizations do not destroy themselves? What if they do not go extinct? What if they simply choose not to expand? What if the assumption that intelligence implies expansion is wrong? We assume that civilizations will expand because life on Earth expands, because humans have colonized every continent, because we have an instinct to explore, to spread, to fill every available niche. But this assumption might be parochial. It might be a projection of human psychology onto alien minds that think in entirely different ways. A civilization 1,000,000 years old might not want to colonize the galaxy. It might have transcended the biological drives that fuel expansion. It might have turned inward, exploring virtual realities, manipulating its own consciousness, pursuing goals that have nothing to do with physical expansion. It might have decided that colonization is pointless, or wasteful, or unethical, or boring. Or it might have discovered something about the nature of reality that makes expansion unnecessary, something about the structure of the universe that changes the cost-benefit calculation, something that we, at our primitive level of understanding, cannot yet conceive. This is the idea behind the transcension hypothesis, proposed by futurist John Smart, that advanced civilizations do not expand outward into space. They expand inward into smaller and smaller scales, into higher and higher densities of computation, into black holes or microscale structures where the computational efficiency is maximized. They do not colonize galaxies, they colonize the Planck scale. They do not build Dyson spheres. They build computational substrates at the smallest possible dimensions, where the laws of physics allow the most efficient processing of information. The logic is compelling. The amount of computation you can perform per unit of energy increases as you go to smaller scales. A planet-sized computer is less efficient per joule than a cell-sized computer. A cell-sized computer is less efficient per joule than a quantum-scale computer. If a civilization's primary activity is computation thinking, simulating, experiencing, then the optimal strategy is not to get bigger, it is to get smaller. The optimal direction is not outward into the cold, empty vastness of space. It is inward, toward the quantum realm, toward the Planck length, toward the densest possible information processing. This would explain the silence beautifully. The galaxy is not empty. It is full of civilizations that have compressed themselves below the threshold of detection. They are everywhere, in every solar system, around every star, but they are too small to see, too small to interact with, too advanced to bother with the crude, wasteful, primitive strategy of physical expansion across space. If the transcension hypothesis is correct, advanced civilizations are invisible not because they are extinct, but because they are very small. Not absent but microscopic, not dead but transcended. The galaxy might be full of civilizations that have compressed themselves into structures too small to detect, too small to see, too small to imagine. Or perhaps the answer is darker. Perhaps the galaxy is not empty. Perhaps it is full. And perhaps the reason for the silence is not absence but strategy, not extinction but hiding. Imagine a forest at night. You are walking through it. You know there are other people in the forest. You can infer their presence from the mathematics of probability. There must be others, but you hear nothing. No voices, no footsteps, no campfires. The forest is absolutely silent. There are two possible explanations. Either you are alone in the forest, or the forest is full of people who are deliberately staying silent. People who know something you do not. People who know that making noise in this forest is dangerous, that the forest contains something, some predator, some threat, some consequence of detection that makes silence the only rational strategy. The galaxy might be a dark forest, and every civilization in it might know something that we do not. Something about what happens when you make noise. Something about what happens when you reveal your position. Something about why the smart play, the survival play, is to stay very, very quiet. This is the dark forest theory, and it is the subject of the next stage of our journey into the silence. The dark forest theory says the universe is full of alien civilizations. They are everywhere, they are watching, and they are silent for one reason, because in a universe of hunters, making noise gets you killed. Every civilization that ever broadcast a signal was destroyed. Every planet that ever revealed itself was sterilized. And humanity has been broadcasting its location into space for 90 years. If the dark forest is real, we may have already triggered our own extinction. In 2008, a Chinese science fiction writer named Liu Cixin published the second novel in his three-body problem trilogy. The novel was called The Dark Forest, and it contained an answer to the Fermi Paradox so elegant, so terrifying, and so logically airtight that it changed the way many physicists and philosophers think about the silence of the universe. Liu Cixin was not the first to propose the idea. Versions of it had been floating around in academic circles for decades. David Brin discussed similar concepts in the 1980s, but Liu crystallized the logic into two axioms and a chain of reasoning so clear that it reads less like fiction and more like a proof. The two axioms of cosmic sociology. First, survival is the primary need of every civilization. Any civilization that does not prioritize survival does not survive. This is not an assumption about alien psychology. It is a tautology. Civilizations that exist are, by definition, civilizations that have survived. Whatever traits they have, survival orientation is among them. The civilizations that did not prioritize survival are gone. Second, civilizations continuously grow and expand, but the total matter and energy in the universe is finite. Resources are limited. Space is vast, but not infinite. Energy is abundant, but not unlimited. Any civilization that grows will eventually need more resources than its home system provides. This is not greed, it is mathematics. Population grows, energy needs grow. The home star has a finite lifespan. Expansion is not optional, it is existential. From these two axioms, Liu derives the dark forest theory through a chain of suspicion. Imagine you are a civilization. You have detected another civilization. You know they exist. They know you exist. What do? You cannot know their intentions. You cannot know whether they are peaceful or aggressive. You cannot know whether they will remain peaceful in the future, even if they are peaceful now. Governments change. Civilizations evolve. A civilization that is benign today might be hostile in 1,000,000 years. And in 1,000,000 years they might have technology that makes them dangerous beyond anything you can defend against. This is the chain of suspicion. You do not know what they think. They do not know what you think. You do not know what they think about what you think. They do not know what you think about what they think. The recursion is infinite. The uncertainty is irreducible. No amount of communication resolves it, because communication can be deceptive. A civilization that says, "We come in peace," might mean it, or might not. And the cost of guessing wrong is extinction. This is not paranoia. This is mathematics. In game theory, this is called the security dilemma. Two agents, each rational, each uncertain about the other's intentions, each aware that the other is uncertain. Even if both agents are peaceful, even if neither has any aggressive intent, the uncertainty itself is dangerous, because you cannot afford to be wrong. The cost of incorrect trust is not embarrassment or loss. The cost is annihilation, the extinction of your species, the end of your civilization, the erasure of everything you have ever built, known, or loved. And the universe makes the security dilemma worse than any terrestrial version. On Earth, you can send diplomats. You can build relationships over years and decades. You can verify intentions through repeated interactions. In the cosmos, the distances are measured in light years. Communication takes decades or centuries. A response to hello might not arrive for 100 years. In that time, the other civilization has had 100 years to develop, 100 years to advance, 100 years to build weapons you cannot imagine. By the time their peaceful response arrives, they might already be capable of destroying you. Now add the technological explosion. A civilization at a primitive level of technology, say, our level might seem harmless. But civilizations develop, they advance, and they advance unpredictably. In 200 years, humans went from horses to nuclear weapons. In another 200 years, where will we be? A civilization that looks harmless today might be an existential threat in a few centuries. And a few centuries is nothing on cosmic timescales. It is a heartbeat. So you have detected another civilization. You cannot know their intentions. You cannot trust their communications. You know they will grow more powerful over time. And the cost of them becoming hostile or simply careless, or simply expansionist, is the annihilation of your entire species. What is the rational response? Liu's answer: you destroy them. Immediately. Before they can develop, before they can become a threat, before they can detect you and make the same calculation. You strike first. Not out of malice, not out of aggression, out of mathematics, out of game theory, out of the cold, merciless logic of survival in a universe with finite resources and irreducible uncertainty. And every civilization that has survived long enough to be dangerous has reached the same conclusion. Every civilization that has thought carefully about the problem has arrived at the same answer. Destroy first, or be destroyed. The universe is a dark forest. Every civilization is a silent hunter moving through the trees. Any civilization that reveals its position, that broadcasts its location, that makes noise, that lights a fire, is destroyed immediately by whoever detects it first, not because the destroyer is evil, because the destroyer is rational, because in a dark forest full of armed hunters, the only safe strategy is silence, and the only response to detecting another hunter is to shoot before they shoot you. This is horrifying, and it gets worse. You do not even need to detect a full civilization. You just need to detect a signal, a radio broadcast, a laser pulse. Any evidence that a planet harbors intelligent life. The rational response is the same. Destroy the planet, sterilize it, before whatever is on it can grow into something dangerous. The method would not even require sending a fleet. A sufficiently advanced civilization could redirect an asteroid, or send a relativistic projectile, a chunk of matter, accelerated to near light speed, carrying enough kinetic energy to sterilize a planet on impact. The victim would never see it coming. At near light speed, the projectile arrives almost simultaneously with the light that announces its launch. Detection and destruction are effectively simultaneous. Liu calls these dark forest strikes clean, efficient, impersonal. Not an act of war, an act of hygiene. The way you might exterminate an ant colony in your garden, not out of hatred for ants, out of an unwillingness to risk the possibility, however remote, that the ants might someday become a threat. Now think about what humanity has done. Since 1974, we have been broadcasting our location into the cosmos. The Arecibo message, a deliberate radio transmission aimed at the globular cluster M13, containing information about our solar system, our DNA, our population, our planet. Since 1936, our television broadcasts have been leaking into space at the speed of light, an expanding sphere of electromagnetic noise, now roughly 170 light-years in diameter, announcing to anyone listening that Earth harbors a technological civilization. If the dark forest theory is correct, we have been screaming in a forest full of hunters for 90 years. And it is not just deliberate broadcasts. Our entire technological civilization leaks electromagnetic radiation, radar signals, television broadcasts, military communications, satellite transmissions, Wi-Fi, Bluetooth. Every technology that uses radio frequencies contributes to an expanding sphere of electromagnetic noise centered on Earth. This sphere is now roughly 170 light-years in diameter. It encompasses thousands of star systems. Any civilization within that sphere, with a sufficiently sensitive radio telescope, could detect that Earth harbors a technological species. We cannot take it back. The signals have been sent. They are traveling through space at the speed of light. They will travel forever. For the rest of the universe's existence, there will be an expanding shell of radio noise carrying the unmistakable signature of human technology. A beacon, a flare, an announcement. In a dark forest where silence is survival, we have been singing at the top of our lungs. Some scientists think this is not a concern, that our signals attenuate with distance and become undetectable beyond a few light years, but this assumes the detectors are comparable to ours. A civilization a million years ahead of us might have detection capabilities we cannot imagine. A Dyson sphere-scale antenna, a detector the size of a solar system. For such a civilization, our feeble radio leakage might be as obvious as a bonfire on a dark hilltop. Stephen Hawking understood this. In 2010, he warned against attempting to contact alien civilizations. If aliens visit us, he said, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. Hawking was thinking about the dark forest without using the name. He was thinking about the logic of asymmetric encounter. What happens when a more advanced civilization encounters a less advanced one? The historical record on Earth is unambiguous. The less advanced civilization suffers, always. The dark forest theory has a chilling elegance. It explains the silence without invoking extinction, without requiring the great filter to be ahead of us, without assuming civilizations are rare. Civilizations might be common, intelligence might be abundant, the galaxy might be teeming with minds, but they are all silent, because they have figured out what we have not yet figured out, that in a dark forest, noise is death. But is it correct? There are serious objections. The theory assumes that destruction is easier than communication, that it is simpler to sterilize a planet than to establish a dialogue. This might not be true. Interstellar destruction is not trivial. Accelerating a projectile to relativistic speeds requires enormous energy. And the theory assumes that every civilization independently arrives at the same paranoid calculus, that none of them decides to take the risk of communication, that none of them builds a coalition, that none of them finds a way to verify intentions. Game theory suggests that cooperation can emerge even among suspicious agents. The evolution of trust in iterated games shows that tit-for-tat strategies, starting with cooperation, often outperform pure aggression. The dark forest assumes a one-shot game, a single encounter with no history and no future. But the galaxy is not a one-shot game. It is an iterated game played over billions of years. In iterated games, cooperation is rational, trust can build, alliances can form. Robert Axelrod demonstrated this in his famous computer tournament in the 1980s. He invited game theorists from around the world to submit strategies for the iterated prisoner's dilemma. The winning strategy submitted by Anatole Rappaport was devastatingly simple. Cooperate first, then copy whatever the other player did. Tit for tat. Start nice. Retaliate if betrayed. Forgive if the other returns to cooperation. This strategy beat every clever, aggressive, deceptive strategy. Niceness won. Not because niceness is naive, because niceness, combined with the willingness to retaliate, is the optimal strategy in a game that repeats. The galaxy is a game that repeats, over billions of years, among potentially millions of players. The dark forest might be the wrong model. The galaxy might not be a forest of silent hunters. It might be a network of cautious cooperators, building trust over millennia, forming alliances through repeated interaction, gradually creating a galactic community based not on fear but on mutual benefit. But then, where is the community? Where are the signals? Where is the evidence of galactic cooperation? If cooperation is the optimal strategy, and the galaxy has had billions of years to implement it, why is the universe not buzzing with the radio chatter of a cooperative galactic network? The silence persists, and no objection to the dark forest theory has satisfactorily explained it, and there is a deeper objection. The dark forest theory assumes that civilizations are fundamentally similar to us, driven by survival, competition, resource acquisition. But a civilization 1,000,000 years old might have transcended these drives, might have solved scarcity, might have developed ethics that preclude aggression, might have evolved or engineered themselves into something that no longer thinks in terms of threats and survival. We are projecting human game theory onto minds that might be as different from us as we are from bacteria. But if they are not hiding from predators, maybe they are hiding from something else. Maybe the silence has a different explanation entirely, one that does not require anyone to be afraid. In 1973, the radio astronomer John Ball proposed the zoo hypothesis. The idea is simple and strange. Advanced civilizations know we are here. They are watching us. They have chosen not to make contact. We are in a zoo, or more precisely, we are in a nature reserve, a protected area, a wilderness that the galactic civilization has deliberately left undisturbed. The reasoning is this: any civilization advanced enough to detect us is advanced enough to contact us. And any civilization advanced enough to contact us is advanced enough to recognize that contact would be catastrophic for our development. It would overwhelm our culture. It would short-circuit our scientific progress. It would impose their frameworks on our minds. The way European contact with indigenous civilizations did not just introduce new technology, it destroyed entire worldviews, entire cultures, entire ways of being human. A mature civilization might understand this, might have made the mistake before contacted a younger civilization too soon and watched it collapse under the weight of premature knowledge. Might have learned, through bitter experience, that the kindest thing you can do for a developing civilization is to leave it alone. Let it develop on its own. Let it make its own discoveries. Let it find its own path. Think about how we treat uncontacted tribes on Earth. There are still isolated peoples in the Amazon and on the Andaman Islands who have never had sustained contact with the outside world. And our policy, the policy of the Brazilian government, of the Indian government, of most anthropologists, is to leave them alone. Not because we do not know they are there. We know exactly where they are. We have photographed them from aircraft. We have mapped their territories. We could make contact at any time. We choose not to, because we understand that contact would be devastating, that our diseases would kill them, that our technology would destabilize their societies, that our worldview would undermine their sense of identity and meaning. This is the zoo hypothesis applied to Earth. We already practice non-interference with less technologically advanced peoples. We already understand that contact across a vast technological gap is harmful to the less advanced party. Is it so unreasonable to imagine that a galactic civilization has reached the same conclusion about us? The zoo hypothesis explains the silence as an act of compassion, not absence but restraint, not indifference but wisdom. The galaxy is full of civilizations, and they all know about us, and they have all agreed through some galactic protocol, some ancient covenant, some universal ethic of non-interference to leave us alone until we are ready. This is hopeful, almost romantic. It implies a galaxy governed by wisdom rather than fear. But it has a serious problem. It requires unanimity. Every civilization must agree to the protocol. Every single one. Because it only takes one rogue civilization, one dissenter, one species that does not follow the rules to break the silence and make contact. The probability that every civilization in the galaxy obeys the same non-interference protocol, with zero exceptions, for billions of years seems vanishingly small, unless the protocol is enforced. Unless there is a galactic authority, a civilization so powerful that it can prevent contact, punish violators, and maintain the quarantine. This is the Sentinel hypothesis, a variation of the zoo hypothesis in which the silence is maintained not by consensus but by force, by a first civilization, a progenitor species, a galactic hegemon that emerged billions of years ago, colonized the galaxy, and now manages the development of younger civilizations the way a gardener manages seedlings. There is an even stranger possibility, one that does not require alien civilizations at all, one that dissolves the Fermi Paradox by dissolving reality itself. In 2003, philosopher Nick Bostrom, the same Nick Bostrom who warned about life on Mars, published a paper called "Are You Living in a Computer Simulation?" The argument is disturbingly simple. Premise 1. Any sufficiently advanced civilization will eventually develop the computational power to simulate entire universes, complete with simulated physics, simulated chemistry, simulated biology, simulated consciousness, simulated beings who think they are real, who look up at simulated stars and ask simulated questions about the nature of simulated reality. Premise 2. Such a civilization would likely run many simulations, billions, perhaps trillions, each one a complete universe with complete physics and complete minds. Conclusion: if this is possible and likely, then the number of simulated universes vastly exceeds the number of real universes, by a factor of billions or trillions, which means the probability that you are in the one real universe rather than one of the trillions of simulated ones is vanishingly small. Bostrom was careful. He did not claim we are in a simulation. He presented a trilemma, 3 possibilities, at least one of which must be true. Either civilizations destroy themselves before reaching simulation capability, or civilizations that reach simulation capability choose not to run simulations, or we are almost certainly in a simulation. One of these must be true, and if you reject the first 2, if you believe civilizations can survive and would be curious enough to simulate, then the third follows with mathematical inevitability. The connection to the Fermi Paradox is direct. If we are in a simulation, the Fermi Paradox dissolves. The universe is silent because the simulation was not designed to include other civilizations. The programmers, whoever or whatever they are, created a universe with one civilization, ours. The rest of the cosmos is backdrop, scenery, an extraordinarily detailed stage set, rendered in exquisite detail, but containing no other actors. This sounds insane, but the logic is valid, and several prominent physicists, including Neil deGrasse Tyson, who has said he gives a 50% probability to the simulation hypothesis, take it seriously. There is a related idea, the planetarium hypothesis, proposed by Stephen Baxter in 2001. The idea is that we are not in a simulation, but in a planetarium, an artificial environment constructed around our solar system by a sufficiently advanced civilization, a cage, a terrarium. The stars we see are not real stars. The galaxies we observe are not real galaxies. They are projections, a constructed sky, a carefully designed illusion meant to make us think we are alone in a vast, empty universe. Why would anyone do this? Perhaps to study us in our natural state, the way wildlife researchers build hides to observe animals without disturbing them. Perhaps to protect us from knowledge we are not ready for, the way a parent might simplify the world for a child. Perhaps to run an experiment to see what a civilization does when it believes it is alone. Perhaps for reasons we cannot comprehend, the way a fish cannot comprehend why it is in an aquarium. The planetarium hypothesis is unfalsifiable by definition. If the illusion is perfect, we cannot detect it. But it illustrates a profound point. We are assuming that our observations of the universe are accurate, that the silence is real, that the emptiness is genuine, that our telescopes show us the cosmos as it actually is, and this assumption might be wrong. Every explanation of the Fermi Paradox assumes the data is correct, assumes the silence is genuine, assumes the emptiness is real. But what if our instruments show us what someone wants us to see? What if the observable universe is a curated experience? This is deeply unsettling because it undermines the foundation of the entire inquiry. If we cannot trust our observations, we cannot trust our conclusions. The silence might be manufactured, the emptiness might be artificial. The Fermi Paradox might not be a paradox at all, it might be a feature of our containment. There is one more possibility, the darkest one, the berserker hypothesis. Named after the science fiction novels by Fred Saberhagen. The idea is that the galaxy is not empty because civilizations hide. The galaxy is empty because civilizations are destroyed, not by themselves, not by the great filter of self-destruction, by something else, something that hunts them. Imagine a civilization, perhaps the first civilization in the galaxy, that decided to ensure no rival would ever emerge. They built self-replicating probes, not von Neumann probes designed to explore, von Neumann probes designed to destroy, probes that travel to every star system, lie dormant, wait for signs of technological activity, radio emissions, atmospheric pollutants, infrared signatures of industry, and when those signs appear, annihilate the source, sterilize the planet, reset the clock. These probes would not need to be fast. They would need to be patient. They could have been deployed billions of years ago. They could be in every star system in the galaxy right now, waiting, listening, silent and ancient and utterly lethal, orbiting in the Oort clouds and asteroid belts of a billion star systems, powered down, dormant, their sensors passive but active, waiting for the electromagnetic fingerprint of a civilization that has crossed the threshold from pre-technological to technological. The threshold might be specific. Not just any radio signal, perhaps a nuclear detonation, the distinctive gamma-ray signature of a fission or fusion weapon, perhaps the spectral signature of industrial pollution in a planet's atmosphere, the chlorofluorocarbons and nitrogen dioxide that betray a species, transforming its world, perhaps the detection of artificial satellites in orbit. Whatever the trigger, the probes know it. They have been programmed to recognize it, and when they detect it, they activate. In this scenario, the silence of the universe is not mysterious at all. It is the silence of a minefield. Everything that ever made noise was destroyed. Every civilization that ever broadcast a signal was sterilized. Every planet that ever produced industrial signatures was reset to a pre-technological state. The galaxy is clean, scoured, patrolled by ancient machines that enforce a sterility that has lasted for billions of years, and we broadcasting our radio signals, leaking our television, sending our Arecibo message might be triggering the mines right now. The signal traveling outward at the speed of light. The berserker probes, ancient and dormant, detecting it, waking up, activating, beginning their journey toward us. We would not know until they arrived, and by then it would be too late. The great filter, the dark forest, the zoo, the simulation, the berserkers. Each explanation for the silence is disturbing in its own way. Each tells a different story about the nature of the universe, the fate of civilizations, and our place in the cosmos. The great filter says, civilizations are rare or doomed. The dark forest says, civilizations are common but terrified. The zoo says, civilizations are wise and watching. The simulation says, there are no other civilizations because the universe is not real. The berserkers say, there were other civilizations and something killed them all. Each of these explanations is internally consistent. Each accounts for the silence. Each has supporters among serious scientists and philosophers, and we cannot distinguish between them. We do not have the evidence to determine which, if any, is correct. The silence does not tell us which explanation is true. The silence is compatible with all of them. This is deeply frustrating. 76 years after Fermi's question, with exponentially more data and exponentially more sophisticated analysis, we are no closer to an answer. The paradox remains paradoxical, the silence remains silent, the question remains open. But notice something. Every explanation we have discussed so far is purely materialistic, purely physical, purely secular. Every explanation assumes that the answer to the Fermi paradox lies in physics, or biology, or game theory, or computation. That the silence is a puzzle to be solved with science. But what if the answer is older than science? What if the religious traditions of humanity, traditions that have been thinking about other worlds, other beings, other realms of existence for thousands of years, have something to say about the silence? What if every religion already answered Fermi's question, not with equations, not with game theory, not with physics, with revelation, with theology, with ancient wisdom about the nature of consciousness, the multiplicity of worlds, and the place of humanity in a cosmos teeming with beings we cannot see? Because when you look at what the world's religions actually say about extraterrestrial life, about other worlds, other beings, other forms of consciousness, what you find is not silence. What you find is the opposite of silence. What you find is a cosmos so full of life, so crowded with beings, so saturated with consciousness at every level and in every dimension, that the real question is not, where is everyone? The real question is, why can we not see them? Islam speaks of multiple worlds, Rabbul Alamin, the Lord of the worlds, plural, not singular. Hinduism describes 14 realms of existence, populated with beings of every conceivable kind. Buddhism maps 31 planes of existence, each teeming with consciousness. Judaism's mystical tradition describes 18,000 worlds. Christianity has a rich angelology hierarchies of non-human intelligence, from seraphim to cherubim, existing in dimensions adjacent to our own. These traditions did not develop in response to the Fermi paradox. They predate it by millennia. They emerge from revelation, from contemplation, from the deepest inquiries into the nature of existence, and they converge on a single extraordinary claim The universe is not empty, it is full, overflowing, crowded with beings. The silence we hear with our radio telescopes is not the whole story. It is not even the beginning of the story. And every tradition has an answer to the question, why can we not see them? Every tradition explains the gap between the fullness of creation and the apparent emptiness of the cosmos. And those answers are stranger, more profound, and more challenging than anything the physicists have proposed. What if God already answered the Fermi Paradox? What if every major religion, Islam, Christianity, Judaism, Hinduism, Buddhism, already told us where the aliens are? Because when you actually read what these traditions say about extraterrestrial life, about other worlds, about other intelligent beings in the universe, the answer is not silence. The answer is the opposite of silence. The cosmos is full, and almost no major religion on Earth says we are alone. Physics has been asking, where is everyone? For 76 years. Religion has been answering it for thousands. The answer, across almost every major spiritual tradition on Earth, is the same. Everyone is right here. The universe is not empty. It is overflowing, teeming, saturated with beings, with consciousness, with intelligence at every level and in every dimension. The silence that our radio telescopes detect is not the silence of an empty cosmos. It is the silence of a cosmos so full that we lack the instruments and perhaps the capacity to perceive what is there. This is not a metaphor. This is not a vague spiritual sentiment. The world's religions make specific, detailed, structural claims about the existence of other beings, other worlds, other realms of consciousness. Claims that predate modern astronomy by millennia. Claims that, in many cases, are more detailed and more specific than anything the physicists have proposed. Let me show you. In Islam, the very first attribute of God in the Quran is not creator. It is not merciful. It is not all-knowing. The first attribute, in the first verse of the first chapter, is Rabbul Alamin, Lord of the worlds. Plural, not the world, the worlds. Not one creation, many creations. The multiplicity of worlds is literally the first thing the Quran says about God. How many worlds? The Quran does not give a specific number, but it is emphatic about the plurality. Alamin is the plural of alam, world, realm, universe. The classical Arabic grammarians noted that the plural form used in the Quran is the most expansive plural, indicating not just 2 or 3 worlds, but an uncountable multitude. Some hadith traditions mention specific numbers, 18,000 worlds, 80,000 worlds, but the Quranic text itself suggests an indefinite, possibly infinite, multiplicity, and these worlds are not empty, they are inhabited. The Quran explicitly states this. Surah Ash-Shura, chapter 42, verse 29. And among his signs is the creation of the heavens and the earth and the living creatures he has scattered through them, and he has the power to gather them together when he wills. Read that again. Living creatures scattered through the heavens and the earth. Not just on the earth, through the heavens. Creatures dabar in Arabic, a word that specifically refers to physical, corporeal, moving creatures distributed throughout the cosmos. And God has the power to gather them together, to bring them into contact when he wills, not when we will, when he wills. The timing of contact is divine, not technological. This is not a mystical verse requiring esoteric interpretation. This is a straightforward statement. God has created living creatures throughout the cosmos and scattered them through the heavens and the earth. The great medieval commentator Fakhr al-Din al-Razi, one of the most rigorous intellects in Islamic history, commented on this verse in the 12th century and argued explicitly that it indicates the existence of life beyond Earth. 800 years before the Drake equation, but Islam goes further. The Quran describes not just physical extraterrestrial life, but entirely different categories of intelligent beings. The jinn, created from smokeless fire, marajin min nar. The jinn are intelligent, conscious, moral beings with free will. They are not angels, they are not humans. They are a third category of intelligent creation. They live in the same universe as humans, but in a dimension we cannot normally perceive. They have societies. They have religions, some are Muslim, some are not. They have families. They have free will and moral responsibility. They can choose good or evil. They are aware of humans. Humans are largely unaware of them. This is a specific, detailed claim about non-human intelligence sharing our universe, not in a distant galaxy, not on a distant planet, here, in the same space, in an adjacent dimension or frequency of existence that our senses and instruments cannot detect. The angels Malaika are yet another category. Pure beings of light, no free will, created to execute divine commands. Billions of them, hierarchies of them. The Quran describes angels with 2 wings, 3 wings, 4 wings, and more, a diversity of forms and functions that suggests not a single type of being, but an entire spectrum of non-human intelligence operating at scales and in dimensions beyond human perception. Surah At-Talaq, chapter 65, verse 12. It is Allah who has created 7 heavens, and of the earth the like thereof. His command descends between them, so that you may know that Allah is over all things competent, and that Allah has encompassed all things in knowledge. 7 heavens and a like number of earths, multiple worlds. Not metaphorical. The classical commentators debated the literal implications extensively. Al-Qurtubi, the great Andalusian exegete, wrote that each earth has its own inhabitants, its own prophets, its own Iblis, its own Adam, separate creations, parallel worlds, each with its own complete ecology of intelligent beings. This is not a fringe interpretation. This is mainstream classical Islamic scholarship. The idea that God created multiple worlds with multiple forms of intelligent life is woven into the foundational texts of Islam. The Fermi Paradox, where is everyone, would be a strange question for a classical Muslim scholar. The answer is obvious. Everyone is everywhere. You simply cannot see them. Yet, Ibn Arabi, the great Sufi mystic and philosopher of the 12th century, known as Sheikh al-Akbar, the greatest master, developed these ideas further than perhaps any other Islamic thinker. In his Fusus al-Hikam and al-Futuhat al-Makkiyah, Ibn Arabi described an infinite cosmos of creation, with beings at every level of existence, each reflecting a different aspect of the divine names. For Ibn Arabi, the cosmos is not a single creation but an infinite unfolding. Every moment, God creates anew, and each creation contains beings, intelligences, worlds within worlds within worlds. The cosmos is a mirror with infinite facets, and each facet contains its own complete reality. Al-Biruni, the great 11th century polymath, astronomer, and physicist, wrote extensively about the possibility of other worlds. He was one of the first thinkers to argue that the stars might be other suns with other planetary systems, 9 centuries before Kepler confirmed it. His reasoning was theological. An infinite God would not limit creation to a single world. The Islamic position is perhaps the most naturally compatible with the idea of extraterrestrial life of any major religious tradition. The Quran's cosmology of multiple worlds, multiple categories of intelligent beings, and divine sovereignty over all creation makes the existence of life beyond Earth not just possible but expected. The silence of the cosmos is, from the Islamic perspective, a test, a veil placed by God over human perception. The veil will be lifted when God wills, not when our telescopes are powerful enough, when He wills. In Christianity, the question of extraterrestrial life has a complicated and fascinating history, because Christianity, unlike Islam, does not explicitly describe non-human intelligent beings beyond angels and demons. The question of whether God created life on other worlds has been debated by Christian theologians for centuries, and the debate has occasionally been dangerous. Giordano Bruno was a Dominican friar, philosopher, and cosmologist. In 1584, he published Dell'infinito, universo e mondi, on the infinite, universe and worlds. He argued that the universe is infinite, that it contains an infinite number of worlds, that each world could harbour life, that the stars are suns with their own planetary systems, that the universe is teeming with life because an infinite God creates infinitely. On the 17th of February, 1600, the Roman Inquisition burned Giordano Bruno alive at the Campo de Fiori in Rome. His tongue was tied so he could not speak to the crowd. His books were placed on the index of forbidden books. His ideas were declared heretical. Bruno was not burned specifically for his cosmological views. His heresies were multiple and complex, including denying the Trinity and the divinity of Christ. But his insistence on the plurality of worlds was part of the case against him. The idea that God had created other worlds with other beings was considered a challenge to the unique status of Earth, of humanity, and of the Incarnation, the central Christian claim that God became human in the person of Jesus Christ. This is the Incarnation problem. If God became human on earth to save humanity, if the entire cosmic drama of sin, redemption, and salvation centers on one species on one planet, then what about life on other worlds? Did Christ die for aliens too? Did God incarnate on other planets? Is redemption universal or local? Thomas Aquinas, the greatest systematic theologian in Christian history, addressed a version of this question in the 13th century. He argued that God could have created other worlds but did not. His reasoning was that a single creation was sufficient to express the divine nature. But Aquinas also acknowledged that this was a matter of God's free choice, not logical necessity. God could have chosen to create many worlds. The limitation was not in God's power, but in God's will. And God's will is, by definition, inscrutable. Other Christian thinkers disagreed. Nicholas of Cusa, a 15th century cardinal and philosopher, argued explicitly for the plurality of inhabited worlds. In his De Docta Ignorantia, on learned ignorance, he wrote that life exists throughout the cosmos, that each star could harbour its own inhabitants, each suited to its own world. He was not burned for this. He became a cardinal. The Church's relationship with the plurality of worlds has always been complicated, not uniformly hostile, not uniformly welcoming. C.S. Lewis, the great Christian apologist and author of the Narnia novels, took this question most seriously. His space trilogy, Out of the Silent Planet, Perelandra, and That Hideous Strength, imagines a cosmos where other planets have their own intelligent species, some of whom never fell into sin the way humanity did. In Lewis's vision, Earth is the anomaly, the silent planet, cut off from the rest of creation by its own rebellion. Other worlds exist in harmony with God. Other intelligent beings live in unfallen states of grace. Humanity is the exception. The galaxy is not empty. It is full of unfallen beings who live in communion with their Creator. Earth is the one world that went wrong. This is a remarkable inversion of the Fermi Paradox. The question is not, why is the universe empty? The question is, why is Earth cut off? The silence is not the silence of emptiness. It is the silence of quarantine. Humanity is isolated not because the cosmos lacks intelligence, but because our particular form of intelligence, fallen, rebellious, broken, has separated us from the community of beings that populates the rest of creation. Modern Christianity has largely made peace with the possibility of extraterrestrial life. The Vatican Observatory. Yes, the Vatican has an observatory, one of the oldest astronomical research institutions in the world, actively studies the cosmos. Brother Guy Consolmagno, a Jesuit astronomer and director of the Vatican Observatory, has said publicly that he would baptize an alien if it asked to be baptized. Pope Francis, in 2014, said he would welcome Martians to the Church. The New Testament itself contains hints. In the Gospel of John, chapter 10, verse 16, Jesus says, "I have other sheep that are not of this fold, I must bring them also." This verse is traditionally interpreted as referring to Gentiles, non-Jewish peoples, but some theologians have wondered whether the other sheep might refer to something more literal. Other beings, other flocks, in other folds, on other worlds. In Judaism, the mystical tradition, the Kabbalah, has the most explicit cosmology of multiple worlds. The Talmud, in Tractate Avodah Zarah 3b, states that God flies through 18,000 worlds. 18,000. Not one, not seven. 18,000 worlds through which the divine presence moves. The Zohar, the foundational text of Kabbalah, expands this dramatically. It describes countless worlds, each inhabited, each with its own form of beings. Hasdai Crescus, the great 14th century Jewish philosopher, directly addressed the question of multiple worlds in his Or Hashem, Light of the Lord. He argued against Aristotle's claim that only one world could exist. Crescus marshaled logical arguments for the existence of multiple worlds, possibly an infinite number, and argued that this multiplicity was consistent with, and indeed demanded by, the infinite creative power of God. His reasoning was remarkably similar to Giordano Bruno's 2 centuries earlier, and without the burning. The Kabbalistic cosmology is structured in layers. The Sephirot, the 10 emanations of divine energy, create a cascading series of worlds. Each world is less directly connected to the divine source than the one above it. Our physical world, Asiya, the world of action, is the lowest. Above it are Yetzirah, the world of formation, Bariah, the world of creation, and Atzilut, the world of emanation. Each world has its own inhabitants. Each world operates according to its own principles. The beings in the higher worlds are more directly aware of the divine presence. The beings in our world, the lowest world, are the most separated from the source, the most isolated, the most likely to feel alone. The Midrash, the vast body of rabbinic commentary on the Torah, contains numerous references to multiple worlds. Midrash Rabbah states that God created and destroyed multiple worlds before creating this one, building worlds and destroying them, until achieving a creation that satisfied divine purpose. The Talmudic sage Rabbi Yochanan taught that God flies through the worlds, suggesting active divine engagement with multiple realities simultaneously. The mystic Rabbi Isaac Luria, the great 16th century Kabbalist of Safed, developed the concept of cosmic repair, tikkun olam, across multiple levels of reality, each populated with sparks of divine consciousness, trapped in material forms and waiting for liberation. This maps onto the Fermi Paradox in a striking way. We feel alone because we are at the bottom. Because our world, the physical, material world accessible to telescopes and radio receivers, is the lowest rung of a cosmic ladder, the beings above us are more numerous, more aware, more connected. But they exist in worlds that our physical instruments cannot detect. Our silence is not cosmic silence, it is the silence of the basement. The party is upstairs. We just cannot hear it. In Hinduism, the question, "Where is everyone?" would be met with bewilderment, because in the Hindu cosmology, everyone is everywhere. The universe is so full of beings that emptiness is inconceivable. The Hindu cosmos contains 14 lokas, 14 realms of existence, 7 upper realms and 7 lower realms. Our world, Bhuloka, the earthly realm, is just one of 14. Above us are Bhuvaloka, Svargaloka, Mahaloka, Janaloka, Tapaloka, and Satyaloka realms of increasing spiritual refinement, inhabited by devas, sages, and beings of extraordinary power and awareness. Below us are Atala, Vitala, Sutala, Rasatala, Talatala, Mahatala, and Patala realms inhabited by asuras, nagas, and other beings. The Bhagavata Purana, one of the most important texts in Hindu devotional literature, describes the cosmos in extraordinary detail. It lists 400,000 species of human-like beings across various planetary systems. Not 400, not 4,000. 400,000 species of humanoid life, plus millions of other species of varying intelligence and form. Devas with lifespans of billions of years, Gandharvas celestial musicians, Apsaras celestial dancers, Yakshas, Rakshasas, Kinnaras, each a distinct category of intelligent being with its own nature, its own realm, its own relationship to the cosmic order. The Vishnu Purana describes Brahma, the creator, as producing an infinite number of universes, not just one, an infinite number. Each universe is a bubble in an infinite foam of universes. Each bubble contains its own Brahma, its own creation, its own 14 realms, its own 400,000 species of humanoid life. The scale is beyond comprehension. The multiverse is not a speculative hypothesis in Hinduism. It is standard cosmology. It has been standard cosmology for 3,000 years. The Bhagavad Gita adds another dimension. Krishna reveals to Arjuna his cosmic form, the Vishvarupa, and Arjuna sees all of creation at once, all worlds, all beings, all times, past, present, and future, collapsed into a single vision of infinite reality. Arjuna is terrified. Not by emptiness, by fullness, by the incomprehensible abundance of creation, by the sheer number of beings and worlds and dimensions that his ordinary human perception had failed to register. The Vishvarupa is the opposite of the Fermi Paradox. It is the moment when the veil is lifted and you see that the cosmos is not empty. It is so full that the human mind cannot process it. Arjuna covers his eyes. He begs Krishna to return to his ordinary form. The truth of cosmic fullness is too much for a human mind to bear. In this context, the Fermi Paradox is not a paradox at all. It is a limitation of perception. Our telescopes scan the electromagnetic spectrum and find silence. But the electromagnetic spectrum is one thin slice of reality. The 14 lokas exist on different planes, different frequencies, different dimensions, different modes of being. A radio telescope cannot detect a deva any more than a thermometer can detect a color. The instrument is wrong for the measurement. The silence is an artifact of our tools, not a property of the cosmos. In Buddhism, the cosmology of multiple worlds is equally elaborate. Buddhist cosmology maps 31 planes of existence grouped into 3 broad realms. The Kamaloka, the desire realm, contains 11 planes, including our human world, various animal realms, ghost realms, and hell realms. The Rupaloka, the form realm, contains 16 planes inhabited by beings of increasing refinement. The Arupaloka, the formless realm, contains 4 planes where beings exist as pure consciousness without physical form. Each plane is inhabited. Each plane contains conscious beings. The total number of beings across all 31 planes is, according to Buddhist texts, effectively infinite. The Buddha described a 1,000-fold world system, 1,000 worlds, each containing its own Mount Meru, its own continents, its own sun and moon, and a 3,000-fold great world system, 1,000 times 1,000 times 1,000 worlds, 1 billion worlds. This description made 2,500 years ago, long before telescopes, corresponds remarkably to the scale of a galaxy. But the most radical Buddhist response to the Fermi Paradox is not cosmological. It is philosophical. The concept of pratitya samutpada dependent origination holds that nothing exists independently. Every phenomenon arises in dependence on other phenomena. Every being exists in relation to every other being. Separation is illusion. Isolation is impossible. The very idea that you could be alone in the universe contradicts the fundamental structure of reality as Buddhism understands it. The Heart Sutra, perhaps the most famous text in Mahayana Buddhism, declares, "Form is emptiness, emptiness is form. Nothing has independent existence. Everything is interconnected. The boundary between self and other, between here and there, between this world and that world, these boundaries are constructions of a mind that has not yet seen through the illusion of separateness. A mind that has awakened a Buddha perceives no boundaries, perceives no isolation, perceives a cosmos in which every point contains every other point, every being contains every other being, and the question, where is everyone, dissolves because everyone and where are both constructions of a mind that mistakes its categories for reality." The Japanese Zen master Dogen wrote in the 13th century, "Each blade of grass, each form and appearance is the entire earth. Each blade of grass, each appearance is all of existence, is all of time. Every point in the cosmos contains the whole cosmos. Every being is connected to every other being. The concept of isolation, of being alone in the universe, is, from the Buddhist perspective, an illusion. Samsara, the cycle of existence, encompasses all realms, all beings, all worlds. Nothing is separate, nothing is isolated. The feeling of being alone in the cosmos is Maya illusion, the most fundamental delusion of a mind that does not yet see clearly." In Zoroastrianism, one of the oldest monotheistic religions, originating in ancient Persia, the cosmos is a battleground between Ahura Mazda, the spirit of truth and light, and Angra Mainyu, the spirit of destruction and darkness. The cosmos is populated not just with humans, but with Fravashis, guardian spirits, and Yazatas, divine beings worthy of worship. Each star was associated with spiritual beings. The cosmos was alive, intelligent, populated at every level with consciousness, engaged in the eternal struggle between truth and falsehood. In the indigenous traditions of North America, the concept of star people is widespread. The Lakota, the Hopi, the Cherokee, the Cree. Dozens of nations have traditions that describe ancestors who came from the stars. The Lakota tradition speaks of beings who traveled between the star world and the earth world. The Hopi tradition describes Kachinas, spiritual beings who mediate between the human world and the cosmic order. The Dogon people of Mali have traditions about Sirius the star that include details about its binary companion that were not confirmed by Western astronomy until the 20th century. These indigenous traditions do not distinguish sharply between physical and spiritual beings the way Western science does. The star people are not aliens in the science fiction sense. They are not technological beings who travel in spacecraft. They are beings who exist on a different level of reality and who interact with the human world through spiritual means. The distinction between extraterrestrial and spiritual that Western culture takes for granted does not exist in these traditions. A being from the stars and a being from the spirit world are not different categories. They are the same category, perceived from different angles. Now, the honest assessment: I have taken you through 6 major religious traditions: Islam, Christianity, Judaism, Hinduism, Buddhism, indigenous spirituality. And in every case, without exception, the tradition asserts that the cosmos is full of intelligent beings. Not one tradition says we are alone. Not one tradition describes an empty universe. The convergence is remarkable. Cultures that had no contact with each other, separated by thousands of miles and thousands of years, independently arrived at the same conclusion. The universe is teeming with consciousness. But I will not pretend this convergence is proof. It is not. The convergence might reflect a deep truth about reality, that human beings, across all cultures, have accessed through spiritual practice a dimension of the cosmos that science cannot yet measure. That revelation, meditation, and contemplation are instruments of perception as valid as telescopes and spectrometers, detecting phenomena that electromagnetic instruments miss. Or the convergence might reflect a deep truth about human psychology that we are pattern-seeking, meaning-making beings who cannot tolerate the idea of cosmic loneliness, and therefore populate the universe with beings born from our imagination. That the jinn and devas and angels and star people are projections of human minds that evolved on the African savanna in small social groups and cannot conceive of true isolation. That we fill the cosmos with companions because we are terrified of being alone. Both explanations are possible. Both are consistent with the evidence, and we cannot currently distinguish between them. This is the honest position. This is where intellectual integrity demands we stand between the religious traditions that assert cosmic fullness and the scientific observations that record cosmic silence, unable to prove either side wrong, unable to prove either side right. The religious traditions make claims about beings in other dimensions, other planes, other realms of existence. These claims are, by their nature, unfalsifiable by the methods of science. You cannot point a radio telescope at the jinn. You cannot detect devas with an infrared survey. You cannot measure the 31 planes of Buddhist cosmology with the Kepler Space Telescope. The religious claims exist in a domain that science cannot currently access. This does not make them false, it makes them untestable. And untestable claims occupy a different epistemological category than the measured silence of the electromagnetic spectrum. The physicists and the theologians are looking in different places. The physicists look at the electromagnetic spectrum and find silence. The theologians look at revelation and tradition and find fullness. Both are reporting accurately on what they see. The question is, which domain is more complete? Which mode of perception captures more of reality? And here is what I find extraordinary. The physicists have been looking for 76 years. They have surveyed thousands of stars, scanned entire galaxies, built the most sensitive instruments in human history, and they have found nothing. Zero evidence of extraterrestrial intelligence. The silence is total. The religious traditions have been looking for thousands of years, using different instruments: prayer, meditation, revelation, contemplation, altered states of consciousness, and they have found the opposite of silence. They have found a universe overflowing with beings, with consciousness, with intelligence at every scale and in every dimension. One of these perspectives is wrong. Or, and this is the possibility that fascinates me most, they are both right. The electromagnetic spectrum is silent, because the beings are not electromagnetic. The physical cosmos is empty because the beings are not physical. The universe accessible to our telescopes is devoid of intelligence because intelligence operates primarily in domains our telescopes cannot reach. The silence is real. The fullness is also real. And the boundary between them, the boundary between the physical and the metaphysical, between the measurable and the immeasurable, between the world of science and the world of spirit, might be the most important boundary in the cosmos. Fermi asked, "Where is everyone?" At lunch in 1950, Islam answered, "Everywhere, in worlds beyond your perception, in forms you cannot detect, scattered through the heavens by a God who creates without limit." Christianity answered, "Here, but we are quarantined, cut off, the one silent planet in a cosmos of unfallen beings." Judaism answered, "Above you in higher worlds, on higher rungs of the cosmic ladder, in realms your instruments cannot reach." Hinduism answered, "In 14 realms, across infinite universes, in 400,000 species of humanoid life, in a cosmos so full that emptiness is the only true illusion." Buddhism answered, "In 31 planes of existence, across 1 billion worlds, in every blade of grass, connected to you by the fabric of dependent origination that makes isolation impossible." Indigenous traditions answered, "In the stars, in the spirit world, in dimensions that your science has not yet learned to perceive." And physics answered, "We do not know. We have looked, we have listened, we have searched, and we have found only silence." Maybe the silence is the answer. Maybe we are alone. Or maybe the silence is the question. And the answer requires instruments we have not yet built, perceptions we have not yet developed, a mode of knowing that science has not yet achieved or has not yet remembered. The universe is either empty or full, either silent or singing, either a vast, cold, purposeless void in which one species on one planet briefly flickered into consciousness before going dark, or a cosmos teeming with intelligence at every level, in every dimension, overflowing with beings that the greatest telescopes in the world cannot see, but that the deepest traditions of human wisdom have always known were there. Both possibilities are extraordinary. Both are humbling. Both demand a response. If we are alone, then we are the most precious thing in the universe, the only consciousness, the only minds, the only beings who have ever looked at the stars and wondered, and the responsibility that places on us to preserve, to protect, to continue is staggering. If we are not alone, if the traditions are right, if the cosmos is full, then our inability to perceive our neighbours is itself the deepest question. Not, where is everyone? But what is wrong with our eyes? Not, why is the universe empty? But why can we not see what is there? Either way, the silence speaks. Either way, the question matters. Either way, you are here in a cosmos that is either achingly empty or impossibly full, asking the question that every conscious being eventually asks. Where is everyone? Maybe the answer is nowhere. Maybe the answer is everywhere. Maybe the answer is that the question itself, the ability to ask it, the consciousness that frames it, the mind that cannot rest until it is resolved, is the rarest, most extraordinary, most precious thing in all of creation. Or maybe the answer is simpler and stranger than any of us expect. Maybe the answer is that we have been looking in the wrong place, that our telescopes point outward when they should point inward, that our instruments measure electromagnetic radiation when they should measure something else entirely, something we do not yet have a name for, something we do not yet have a theory for, something that the mystics and prophets and contemplatives have been trying to tell us about for thousands of years in languages that science has not yet learned to speak. The physicist David Bohm a colleague of Einstein, one of the most profound thinkers of the 20th century, spent his later years studying the implicate order, an underlying level of reality from which the physical universe unfolds, a level where separateness dissolves, where the distinction between here and there loses meaning, where consciousness and matter are not separate categories but different expressions of the same underlying reality. Bohm was not a mystic, he was a rigorous physicist, and he came to believe that the universe our instruments measure is the surface of something much deeper, much stranger, much more connected than physics has yet imagined. If Bohm was right, if there is a deeper order beneath the physical, then the silence of the electromagnetic spectrum tells us very little. It tells us that the surface is quiet. It says nothing about the depths. And maybe that is enough, for now, until we learn to see what the silence is hiding,